Hello. Hi, Lichan. How are you? Hello. Yes, yes. Yes, yes, yes. Yeah, I can phone her. Can phone her. Now quite free. Only start in after Chinese New Year. One coming in. Uh, yeah, God has been good lah. Providing her, give her a break, and then come another one come. So usually she prefer to take care of two lah. Then the two babies can play together lor. No choice lah. To pass time. Okay, you can try the rest yourself. I didn't try all the rest also. If you need to ask question, let me know. I will try it out because I'm also like you. I have to work every day, except weekend. I have to prepare all this PowerPoint. It takes time.
But I thought you were retired, je.
I'm retired, but I have to teach you. So I have to prepare everything beforehand.
Oh,
Right? Cannot not ready. Teaching online have to be ready. Let's go to structure question. Right? So morning I do structure. I do the solving problem. I try out more or less all the questions. That's why I can understand better. Then afternoon I prepare your lecture for you. Now I'm in optics. Now finishing optics. So that's why I can go with you on Friday. And then I'm now starting on the next topic, which is wave optics. Right? Okay, let's go to structure question number 1. A guitar string of length 54.5 cm emits fundamental note of 256 Hz. Calculate the speed of transverse wave on the string. How to do that? How to do that? Yeah, those questions we have not done. If you want to do it, you can do it and then send it to me. I will mark for you. Because you have to learn how to answer the question. Even the term 1 and term 2. You can try some of the question and you want, you can pass it up. I'll mark for you. Okay. How to find the wavelength?
Pi over 2, lambda over 2 equals to 0.545.
No. Okay. Right? In your mind, fundamental mode is just that one loop. And then node is half lambda equals to L. So lambda equals to 2L. Right? Take the 2 across there. So from there, you can calculate your half lambda 1 equals to 54.5. And calculate your wavelength. And then after that, you have given the frequency, you can calculate the speed. F lambda 1. That's the frequency. That's the wavelength that we have calculated. You can convert that cm to meter and get your answer. The tension in the string is increased. Discuss a change in frequency of the node emitted. Okay, you can discuss with me. The tension increases. So what will happen? Yeah. Right? We are still ahead. We are still almost finished what your school finished. Right? Your school haven't started your geometrical optics yet. So we will start on
Yeah, I
Friday.
never start chapter 4 yet.
So you start on Friday. So we are still ahead of you. That's why I say we don't need to replace a class. You can still afford to cancel one or two classes. Okay.
Yeah, practically last week the entire class never sit lecture.
Yeah, no point in replacing. As I say, you need more time to study, more time to do your homework. Unless you are behind time.
But now you're ahead, right?
Yeah, you should be ahead already by Friday. Ahead of your teacher. So what happened? The tension increase in the string.
His increased fundamental frequency is higher.
Must go back to the formula. This is the formula. Tension increases. This is still constant. So the speed will increase. Right? That one, the length is still same. You still got one loop. Wavelength is the same. Speed increases. So frequency also will increase. That's how you decide. You argue it out. Okay. Any comment?
No, sir.
Okay, let's go to part B then. Am I recording? Okay. Part B. The string of frequency 256 Hertz and another string of frequency 264 Hertz are played at the same time. What is the frequency of the beat? How to find the frequency of the beat? Yep. Yes, yes, yes. How to find the frequency of the beat? Subtract, oh? Right? Just subtract. That's the frequency of the beat. 8 Hertz. Okay. Go to the number 2. Ambulance with siren emitting a sound of 600 Hertz. Move with speed of 30. Speed of sound is given. Calculate the frequency of the siren heard by the stationary pedestrian who is behind the ambulance. Okay, as I say, that's an important formula that you must remember and know how to use it. Right? This one observer is not moving. So that one is 0. This speed of the source that is emitting the sound. Okay. So frequency of observer. Right? Where is it? Where is it going? Right? Remember the siren is moving to the right. The observer is at the left. So it means that the sound source is moving away. The speed of sound is moving the other way. Two of them are in opposite direction. That's why we choose a positive. Okay. And put in your value. Speed of sound. That's your speed of sound. Speed of source. That's your speed of source. And the original frequency. That's original frequency. Calculate out. Calculate the frequency of the siren heard by the driver of a car moving with speed 20 meters per second away from the ambulance in the opposite direction. So what should I do? This one. What formula should I use? Yep. Yep. Should I choose positive or negative?
Negative.
For the top, negative, is it?
Yeah.
The bottom?
Positive.
Okay. The source
Yeah,
of the
actually, why you decide what is up negative, why is down positive, and vice versa?
this observer, speed of observer.
Okay.
So you have to ask yourself, observer is moving away from the source, right? And the speed of sound and the speed, the direction of sound wave and the direction of observer are in the same direction. Yep.
Moving away means negative lah.
No, you have to decide yourself. First of all, this is the observer, and then look at the reference to the sound wave. The observer is moving away, right? Observer moving away, and the sound wave is moving towards the observer. That means they are moving in the same direction. Whereas the source is moving away, right? And the sound wave is moving. Remember, you must look at the observer. The observer, with reference to the sound wave, they are moving in different directions. The sound wave is moving to the left, the observer is moving to the right. So that's why we choose it positive here. Right? Sorry. This part, they are moving in the same direction. Observer and the sound wave. That's why we have to put a subtraction there.
Oh.
Can or not? Can or not? Can or not?
Okay.
Can or not? Can or not? What is the problem?
No, it's okay. Explain one more time again.
Okay. Look at this picture. Right?
Yes.
There is a siren moving to the right. There's the observer moving to the left. Okay. So as far as we look at the top is the observer. Observer is moving to the left.
Yes.
The speed of wavefront is moving to the left also. So we choose subtract.
That means it's away lah.
As long as the two are in different direction.
Then minus. If it's same direction, only positive.
If they are in the same direction, then it should be negative.
Positive.
This one is they are in the same direction. Their wavefront and the observer are in the same direction. That's why we choose negative. Whereas the siren, right, for this part, we are looking at the observer that's stationary. The bottom one, we're looking at the observer that's stationary. And we are looking at the source of sound, moving to the right. The wavefront is moving to the left. Right? Both of them in different direction. So that's why we choose positive. No? Yep.
Isn't it supposed to be the opposite way? Why? Because they are in opposite direction. What?
Yeah, opposite direction we should add.
Not negative, man.
They are moving faster away. Negative is where this one is the observer is moving to the left.
Yes.
Right? The sound wave is also moving to the left. That's why we choose negative.
No, but both going to the left means not champo.
No. When they are in the same direction, we subtract. Always remember that.
Any for this chapter lah.
Right? Both the same thing you have to decide. Right? The top there, positive or negative. The bottom there, positive or negative. Right? For the first part, we have first part is ambulance with siren on, move with a speed this one. Right? So calculate the frequency. Yeah, this observer is stationary. It's moving towards the observer. Right? So that one is 0. Observer is not moving. Then the wavefront, right? There is the source, the speed of the source. Sound wave is also in the same direction. Sorry, am I doing the right thing? This one is calculate the frequency of siren. heard by the station observer who is behind. This one is this observer, not this observer. Okay, so for this part, Vs is moving to the right, the wavefront is moving to the left. So that's why we add them up. Yeah.
Okay.
That's why I say you must do the question. I do the question, that's why I can understand. You don't do the question, you will always be lost. Okay with that?
Okay.
Okay, so if you have a, you put a negative here, you get 520. Okay, this one, a wave pulse propagating in a string from left to right is shown in the diagram below. Sketch the form of the reflected wave if P, the NP of the string is tight. Right? Tight, it cannot move. So it'll be reflected downwards. Right? Like this one. Right? This is what you said. This one is reflected. Whereas if it's tied to a bangle which move freely along the rod, right? Bangle is just treated as a ring. No, if you don't understand what is the word. Treat as a ring, it can move up and down. That's good enough. Right? Something that can move up and down. So as the wave comes, as the pulse comes, it can move up with the pulse, and then it can move down. Right? So it will be reflected in opposite direction, not inverted. This is inverted. This one not inverted. Same direction. Right? Vertical. That's all. Okay. State the difference between resonant frequency in a closed pipe with an open pipe. Yeah. Anything you want to say? Yep. You have to start studying already. You cannot afford to not study. You have to push it in already this semester work. Yep. See the difference between the resonant frequency in a closed pipe and then an open pipe. Can? Right? Just have a picture. What is happening? Then you can state. Right? That is a fundamental mode of vibration. There's a quarter L equals to a quarter wavelength. This is L equals to lambda over 2. Right? So closed pipe. That's a closed pipe. That's a fundamental wavelength. L is the length of the pipe. V is the speed of the wave. So your frequency F1 is just your V over lambda 1. Lambda 1 is 4L. Right? You can memorize, go ahead. Cannot memorize, work it out. Then the frequency is Fn. Right? For closed pipe is odd numbers, N is odd numbers. Open pipe, right? Half lambda L naught is different wavelength. So that's why we call it 1 naught. Right? That's your half. Half is half equals to L. So fundamental frequency for open pipe is V over lambda 1. That's a lambda 1. Right? Is 2L. So you can see the difference now. And then your Fn is N F 1 naught. N is 1, all the whole numbers. So we know that F1 naught equals to 2F1. Yeah. Okay. Any comment?
No, sir.
If the standing wave in a pipe is not propagated, how would the sound from the pipe still be heard? Yeah. Any idea? The incident and reflected wave interfere constructively in the pipe to produce a sound. Yeah. So when the sound is produced, the sound is moved out. The sound that is produced by the standing wave is the one that is moving out. That's why you hear, not the original waveform. Okay, it's produced in the pipe. Can the sound is produced in the pipe, whether it's closed pipe or open pipe, doesn't matter. It's produced in the pipe, and that's the sound is the one that is traveling out. Can or not?
Can last back teacher later.
Okay, after that, let's go and do essay. Do one last one. Sound is produced by a stretched string. Frequency of the second harmonic is 165. Calculate the length of the string. Okay, how to calculate? Yep, how to calculate? Yep, how to calculate? You have to start reviewing it already. If not, you are going to lose out already.
2F not.
What is it?
2F not. 2F not.
Yeah, how to calculate the length of the string? How do you get to F naught? I must know the shape, second harmonic. That's the second harmonic. Right? So the wavelength, lambda 2 is equal to L. Right? So lambda 2 is equal to speed over F2. So speed is given. Calculate your lambda 2. And you want the length. So that's the length of L equals to lambda 2 equals 2 meter. Frequency of the second overtone. Second overtone is the third harmonic. Right? Second overtone is the third harmonic. So it's n equals to 3. So if you want, you can calculate the right? Know that for the stretch string, Fn is nf1. So calculate your fundamental frequency first. Right? 165 is second, n equals to 2. So calculate your F1. Then you want the third harmonic. Third harmonic n equals to 3. So F3 is 3 times that, fundamental. Get your answer. Okay. You can try the rest. Want me to mark, you can send it to me, no problem with me. Let's go to essay there. I won't do the first one now, because the first one, I think the author makes some mistake there. Cannot be like that. It must be a note there. So we won't discuss the first one. Let's try number 2. What do you understand by the phenomenon called Doppler effect? Explain the effect of this phenomenon when a sound source of constant frequency moves towards a stationary observer. Okay, what's Doppler effect? That one you have to start memorizing already. Memorize and then without looking at the book, write down. That's how you study and force it into your head. Once a while, revise. Yep, what's Doppler effect? Can you remember? Right? Doppler effect refers to the apparent change in frequency of sound when there is relative motion between the source of wave and the observer. Okay, next part. Explain the effect of this phenomenon when the sound source of constant frequency moves towards the stationary observer. Okay, try to do that. Explain. Sound source move towards the stationary observer. Yep, yep. Can. Right? Best is to have a picture of what is happening. Like here, that's the observer. That's the wavefront moving to the observer. So he see shorter wavelength, or he hear shorter wavelength. So higher frequency. Okay, you can memorize the picture in your head, then it's easier to. Okay, wavefront approaching the observer appear of shorter wavelength or higher frequency. Okay with that? Okay, let's go to 2B. A tuning fork is placed above the open end of a vertical tube containing water. The length of air column above the water surface the tube can be varied. When the length of this air column is gradually increased from 0, resonance is seen to occur for the first time when the length of the air column measured from upper end to the tube is 0.5 meter. Resonance means you can hear a sound. Resonance takes place for second time when the length is 48.8 meter. Determine the wavelength of the note emitted by the tuning fork and explain the steps in your calculation. Okay? So have a in your head, either you draw or in your head. That is your mode of vibration. Remember here, the wavelength or the frequency is constant, but you are changing the length of the closed tube. Right? So the first one, L1, this is L1. Right? There's an end correction there. Right? Because the antinode is above that. And let the wavelength be lambda, so it's quarter lambda. Then the next one, L2 plus your end correction at the end there, slightly above that. Right? This is 3/4. Right? This is half plus another quarter. That's why you got 3/4 wavelength. So you can subtract. Right? L2 minus L1, the end correction goes off because end correction is constant in value. Then this one subtract that is lambda over 2. Then your lambda is 2 into L2 minus L1. So this is 2, this is L2, this is L1. Got that? Right? We have done that step by step. Then tell the examiner E is the end correction. Sorry, you have to tell the examiner E is the end correction. Okay, anything not clear?
So far, okay lah. Sure.
Okay. Right, let's finish this one. The wavelength of the note emitted by the tuning fork with frequency 520 Hz is 0.6 meter at 17 degrees Celsius. If the density of air at 17 degrees Celsius and pressure is given, as the pressure, the density of air. Right? Calculate the value of gamma equals Cp over Cv, where Cp and Cv are principal heat capacity. Okay, this one may not be in the syllabus. Okay, but doesn't matter. You can calculate out. Right? Speed is Vf times lambda. So you want your speed, 512 is the frequency, wavelength is 0.66 meter. Calculate the speed. Then this is a formula. Right? Gamma is your gamma. Pressure over density. Then you square it. Take the rho across there. Take the P down. That's why you get this formula. And put in your speed square. Density is given. Pressure is given. Okay? Write it down there. Calculate out. That's how you calculate your gamma. Okay. Any more questions? If not, we will stop here. Anything else you want to ask? Since you're not ready,
So far, no.
No point in me. You can do it, and then if you want, you can pass it up. Friday, we will start with next topic, the fourth topic for this semester.
Yeah, just afraid to attempt, but I'll try lah.
Yeah, try. No harm in trying. If you can accomplish the impossible, good effort. That's what you'll be doing in your whole life in university also. Have to start now. Okay.
Have to try only lah.
Yeah, give your best shot. You have to be serious from
Okay.
now onwards. Anything else you want to ask?
No, Chair. We should stop here now.
If not, we'll stop here.
Topic 4. Okay. Thank you, Chair.
Okay, bye-bye. See you on Friday.
See you on Friday. Thank you.